In these difficult times, it's important that we find positives. So I thought we'd make a short film about what we're working on to make the planet a cleaner and a healthier place for the generations to come. Our mission has its origin in space, where the orbits of the Moon and the Sun create tidal movements in our oceans from the forces of gravity. Where tidal movements are channeled between land masses or around headlands, the flows can become accelerated, like giant, deep rivers. With water being over 800 times the density of air, these tidal streams offer a colossal source of renewable power that is as predictable as the orbits that create them. Our team at Orbital have spent over 17 years developing a revolutionary technology aimed at harnessing this resource, with a mission to provide sustainable clean power to millions of people, homes and businesses around the world. In 2016, we launched the SR2000. At 2 megawatts generating capacity, it was the world's most powerful tidal turbine ever to go into operation. We installed it in the waters off the Orkney Islands in Scotland at the European Marine Energy Centre, where it was exposed to some of the harshest tidal conditions on the planet. Not only did it break records in power production, but it totally validated our novel approach to solving the tidal challenge by attaching turbines to a floating platform rather than a fixed structure on the seabed. That way we can build and install turbines at far lower costs, whilst ensuring we can service them cheaply and quickly, with technicians accessing the turbine like a mechanic stepping onto a boat. The SR2000 was a breakthrough, but we knew we could do better, generate more power and do it cheaper. That's always our goal. So, with over 100 years of engineering experience behind us, and climate change getting ever worse, we set about a redesign knowing we had to be bold. We had to push the limits of engineering and imagination. Through that, we came up with the O2. So the principles of the technology are really simple. We have a main tube structure that acts as our hull, floating on the surface, and that's moored with an anchoring system. And inside there we have a lot of the power equipment and electrical control stuff. That can be accessed quickly and cheaply on the surface. Now underneath the hull, we have 2 leg structures. At the end of each of these legs are our power generating nacelles with rotors that are capturing the energy from the tidal currents. And the clever bit of the technology is, we know that we need to do servicing and maintenance on these nacelles. So when we do that, the entire leg structure is hinged so that we can bring it up to the surface to be able to get low cost, easy access to those nacelles. This is the solution for low cost tidal stream energy. But building it this size just wouldn't generate enough power. We need to think about doing it bigger, much bigger. The floating superstructure is the same length as a 747 Jumbo, with 18-metre-long legs supporting 100-ton nacelle assemblies. At over 10 metres in length, the O2 will have some of the longest blades ever seen on a tidal turbine, giving it a total swept area of over 600 square metres, or about the same area as 1¼ basketball courts. And from that, at full power, the turbines will be able to generate 2.5 megawatts of power at rotor shaft. Each of the mooring lines for the O2 is strong enough to pick up over 20 double-decker buses. In service, a single O2 will be capable of generating enough clean power to meet the annual demand of over 1,700 UK homes. And we're super excited. We're building the first one right now. It's going to be like nothing this world has ever seen before. To help us, we've called on a supply chain that spans the UK and Europe. And proudly, we've drawn on our engineering heritage from home, right here in Scotland. Scottish steel has been worked into the world's most powerful tidal turbine, on grounds where once Scotland drove at the forefront of the Industrial Revolution. That just seems fitting on every level. From old industries, we can build new ones. New industries for a cleaner future. A future that depends on curing climate change. Solutions are needed now, more than ever before, if we're to give our children a healthy, sustainable planet. So please, follow our mission to turn the tide and become a solution.
I help design and build tidal turbines. That's I guess the main bit. I take care of the structural side of things and the mechanical engineering side. There's a lot of work to be getting on with because we're building the world's most powerful tidal turbine. At 72 metres, it's going to be big, and it weighs approximately 680 tonnes. People have always been looking for novel ways to kind of work with the environment rather than work against it. So I'm going to be in Dundee for a good little chunk of my life. I'll be spending a lot of time in a shed helping assemble the turbine. As a youngster, I remember growing up in Orkney, watching the tide rip through the Pentland Firth and thinking that it would be really cool if somebody did something with that. All these years later, I'm working for a company that's building a machine to harness some of that energy. It's going to be part of a bigger movement, a bigger direction change in the way that society harnesses its energy.
Renewable energy is a big part in Orkney. It has been since the first wind turbines. No, I feel really proud of that. It's kind of something, being from an island, you're proud of what you do, you try and put in as much as you can, and it's rewarding. I'm the lead technician at Orbital Marine Power. So I'm responsible for the outfitting on site. You can't buy the parts for a tidal turbine off a shelf, so it's kind of everything we do, we have to make unique. And being a marine environment, it just gives everything that extra challenge to make sure it's going to work, going to last, going to do what it's supposed to do. So I work with a really great team, from the engineers to the technicians. We all get on very well. We're all kind of for the same goal. We want to see ourselves doing something that's going to benefit kind of our community, or even further afield. Is going to be the next big thing. Now, I really like going fishing with Dad. It's just a bit of time between us.
This is a chance just to get us time. There's nobody else there. Switch off mobile phones and take a packed lunch. It's a great way to spend a good day. Yeah, I'm quite proud that Ryan works for Orbital Marine Power. Pretty pleased that he's gotten a footing in that industry because it's the way forward.
So we're currently working on a project that's the first of its kind in the world. The O2 turbine should power around 1,700 homes, so that means you'd only need 10 of them and you could power the whole of Orkney from tidal energy, which is pretty amazing. Next year will be pretty exciting. We've got the launch of the O2 turbine, and I'm also expecting my first child with Brett, so it's going to be a pretty busy, hectic year. Dad's pretty excited about becoming a grandfather. I think it means a lot to him.
Another one we can take fishing, and yeah, great news.
I think part of being an island is being self-sufficient, so we can harness the power from the tide, which we've got loads of, and power our homes, our houses, and make electricity from it. It's just pretty amazing when we can be leading the way in this technology in the world.
Our goal at Orbital is electricity from the ocean. Clean, predictable power from the tide that you can use for your brew. That's our mission. Helping to power our lives. I'm Finlay Wallace and I'm the Blades Manager at Orbital Marine Power. The turbine blades are the contact point for extracting tidal energy, designed equally for strength and efficiency, and they do a really challenging job. Our blades are made out of composite materials, like fiberglass and carbon fibre. They give the blade the strength and stiffness it needs to do its job. The difference between wind and tidal turbines is the environment. Seawater is 800 times more dense than air. This influences every aspect of the blade design. I've brought you to a field next to where I live because I wanted to be able to show a visual comparison between wind and tidal turbine blades. So the turbine behind us has a power output of about 11 kilowatts and a blade length of about 6 meters. When I checked the numbers and I found that equivalent tidal turbine rotor would have blades of about half a meter. To me it shows that the tide is a good place to be generating power. Generating the same power output using smaller blades means the blades are subject to much greater forces. Safely dealing with these loads in a more compact structure is a critical part of the design challenge. A big part of my focus when I'm engineering the blades is to generate smooth shapes for water to flow. Kind of transfer that back to my board design, the rails and the bottom contours and the shape of the board, imagining how it will move in the water. I've been lucky to be able to use the skills that I've gained from work to apply them to my own little projects. The sea is where I go to kind of reset and to relax. This is research and development. It hasn't been done before in the way that we're doing it. We're blazing a trail.
I moved to Orkney because of the ocean. And then just staying here made sense. It's just like a really nice place to be. I'm Daniel Wise, Head of Offshore Operations for Orbital Marine Power. Challenges. Yeah, we've got some good challenges. The turbine itself is 74 meters long and it weighs nearly 700 tons. And we're going to anchor it at the Falls of Warness in Orkney, in the tidal channel where the tide rips through at 10 miles per hour. The challenge is keeping it there. Don't forget, this is where the Atlantic Ocean and the North Sea meet. It's a perfect place for generating tidal energy. This is a big turbine, capable of generating a lot of power. So we're not talking about small anchors here. We're dealing in hundreds of tons. So that takes a lot of planning, a lot of preparation, and a team that can execute with precision in what is a dangerous environment. It's critical that it's done right. In my own time, I've got a general interest in marine conservation and have done all my life. Because of the geography of Orkney and also because of the strong tides, the marine environment is really unique. I place cameras to record images of endangered skate species. We think the back of the fish is so unique to each individual that we can recognize them from the markings on their backs. And we use that information to find out the best way to protect them. It's widely accepted now that us humans need to make a change in how we see and use energy. What we do know is that there's a vast amount of energy in the tides, and we've got a technology that can harness that energy. The rewards are big. I think the production of electricity from the tides, it's clean energy. It's a must-have because we owe that to our future generations.